Welcome. In this video, we'll discuss why generative AI models require a fundamentally different validation approach and demonstrate how to generate custom datasets, evaluate model responses, and perform comprehensive validation testing using Nimbus Uno, an enterprise AI analytics platform by Solytics partners.
Generative AI models operate very differently, making the process of validation a bit challenging. Traditional models usually generate numeric outputs, whereas generative AI models produce outputs in the form of text, images, or even code, making them far more complex to validate. Because of this, a new approach to model validation is required. These models are also continuously evolving, which adds another layer of challenge. In traditional model validation, the process typically involves assessing conceptual soundness, testing model assumptions and performance, analyzing stress and sensitivity scenarios, and finally preparing a model validation report. However, validating generative AI models is quite different. These models are trained on vast and diverse datasets, with parameters running into millions or even billions, and are often third-party vendor models such as GPT or Gemini. Hence, it becomes important for use to validate these models by generating relevant data for the use case or application. Therefore, the first step in validating such models is to generate specific data tailored for the validation exercise. For example, when validating a RAG-based application that answers customer queries from internal documents, we begin by creating ground truth question-answer pairs from those documents. Once this dataset is prepared, we then test multiple large language models, evaluating their output quality and relevance. The next step involves human annotation and manual review, where selected samples are carefully assessed for accuracy, coherence, and factual correctness. The model response is compared with human confidence scores using a conformal prediction assessment. Finally, insights from these tests are consolidated to generate detailed validation reports, providing a comprehensive view of model performance and compliance. The Nimbus platform has been purpose-built to address this very challenge, enabling users to generate data, create custom prompts and responses, and perform all validation and comparative analysis activities seamlessly within one environment. The process begins with the Data Generator module. Here, users can generate customer queries and corresponding reference answers directly on the platform. Nimbus comes equipped with a predefined library of question types, ranging from simple factual question-answer pairs to more complex causal reasoning, multi-hop, and adversarial questions designed to test model robustness. This is achieved through an intelligent knowledge graph-based approach. For example, if you have a 20-page standard operating procedure (SOP) document, Nimbus automatically extracts meaningful text chunks and constructs targeted questions based on these sections. For each question, the platform maintains both the reference answer from the document and the model-generated answer, allowing you to directly compare and assess output quality. Through this mechanism, Nimbus validates the entire RAG pipeline, assessing both retrieval accuracy and generation quality. Users can configure the process flexibly, selecting any number of documents, queries, or question types depending on the validation scope. If the pre-built combinations aren't sufficient, the query builder lets you define custom rules, specify the domain or topic, and generate tailored question sets aligned with your use case. Once the dataset is generated, it flows into the Data Intelligence Hub, where users can visualize and review all question-answer pairs, provide feedback, and even trace back how each question was generated. This feedback can then be used to fine-tune the question generation process and enhance future validations. Nimbus also provides complete transparency by displaying the underlying knowledge graphs used in the process. These graphs represent the entity relationships extracted from the document, for example, subject, predicate, object structures, which are then used to automatically generate multi-hop or reasoning-based questions that challenge the model's depth of understanding.